Alright guys, sorry that I'm not going to be with you guys today. I want to try to show you two other ways to solve a quadratic equation. And one of them deals with square roots, which you sort of already know about, and then the other one deals with something called the quadratic formula. So let's first deal with the idea of square roots. So when I look at square roots, the goal is for me to get x squared by itself, or whatever is being squared by itself. So I'm looking at x squared equals 54. My x squared is by itself, so all I have to do to get rid of x squared is take the square root of both sides. So when I do that, I get x equals the plus or minus square root of 54. When I'm taking the square root of something, I can have two possible solutions, a positive or a negative version of that number. So when I look at 54, I can break it down. I know it's 9 times 6, which is 3 times 3 times 6, 2 times 3. So it looks like my solution would be x equals plus or minus 3 radical 6. So if I look at another one that's very similar to this, like in number 2, I have r squared equals 48. So my r squared is by itself, so all I need to do is take the square root of both sides. So when I do that, I know I'm going to have two possible solutions, square root of 48, and then I just got to break down 48. So I know 48 breaks down to be 8 times 6, which is 4 times 2 times 2 times 3, 2 times 2 times 2 times 2 times 3. And remember, we are looking for pairs. So for every pair of something, I take one out. So I have two pairs of 2's with a 3 underneath. So my solution would be plus or minus 4 radical 3. In this case, do I have x squared by itself? No, I need to get x squared by itself. So what do I need to do? I need to get rid of the negative 4. So I'm going to divide both sides by negative 4. Okay? So when I do that, I get x squared equals 15. Then I'm just going to square root both sides. And I just get plus or minus square root of 15. If I look at 15, 15 breaks down to be two prime numbers, 3 and 5. So that would be my final answer. Remember, with square roots, I can only do square roots when I have two terms. One that's a squared and one that's c. If I have a b term, I cannot use square roots to solve it. So when I look here, I have x squared minus 1 equals 3. So I want to get x squared by itself. So what I'm going to do is add 1 to both sides. So when I add 1 to both sides, I get x squared by itself, which is going to be 4. I'm going to square root both sides. And when I do that, I get plus or minus 2 to be my solution. So remember, the goal is that I want to get whatever's being squared by itself. So when I look at number 5, I want to get x squared by itself. Okay? So what I want to do is I want to get x squared right there by itself. So I have to get rid of the 5 first. So I'm going to add 5 to both sides. So I get 8x squared equals 32. Now, x squared is not by itself yet, so in order for me to get that by itself, I have to divide both sides by 8. So I get x squared to be 4. And now to get x squared by itself, I just square root both sides. And I get x to be plus or minus 2. Okay? So with square roots, I'm trying to get whatever's being squared by itself. So when I look at number 6, I have 4x squared minus 6 equals 194. So I want to get x squared by itself. So that means I have to get rid of the minus 6 and the 4. So I want to get rid of the minus 6 first. So I'm going to add 6 to both sides. And I end up with 4x squared equals 200. Okay? So I want to get x squared by itself, so I need to get rid of the 4. So I'm going to divide both sides by 4. And I get x squared to be 50. Now, I'm just going to square root both sides. And I get plus or minus square root of 50. 50 breaks down to be 25 times 2, 5 times 5 times 2, so it turns out to be 5 radical 2. So my solution is going to be plus or minus 5 radical 2. Okay, so that's square roots. I'm going to talk about quadratics in a second, but I want to give you guys a little break and have you guys try some problems that deal with square roots. So talk to you later.